what we call electricity. What do you know about electricity? Because you have to do electricity, formulas on it, and examples for us to know how to apply it in our day-to-day activities. Electricity in this modern age is gone a long far away, because no matter how it is, we do apply electricity on our day-to-day activities at what we are doing. Now, electricity holds important roles. Maybe in television, computers, radio, we make use of electricity as a current, because electricity comprises of electricity, which is the flow of current, and through it we have some things whereby it can make use of electricity, like battery, cells, because cells are the chemical reactions, and then batteries is the combination of the cells for us to make use of cells. And then we have some calculation on it, because moving of electricity, because we have charges in it, which is we have cathode and anode that make use of electricity. But before electricity can be made, we must have what we call an ions, which is comprises of cations and anions. Those are the ions. Those are the ones that flow, because we can feel it, but we can't see it. We can only just sense the flow of the charges, flow of the ions in it. We call it electrons, because they are the flow of the current. They are the one that will allow the flow of the current. And what do you know about the cathode? Cathode is just is the negative charge. It's negative charge in electricity, because if you have a metals or any conductor that make use of electricity, because it's only metals and semiconductor that can conduct electricity. The semiconductors, that one can conduct sometimes and that one cannot conduct sometimes. It depends. If you add impurity on it, if you add impurity on the semiconductor, it will conduct. But if you didn't add impurity on the semiconductor, it won't conduct. Like doping it. If you dope it, the semiconductor, it will conduct electricity. But normally, conductor, which is our, let's say, a metal. Let's drill a metal. Let's say this is our metals, and we have the first charge, first part, which is negative charge, which is we call a cathode, and the positive charge we call it an anode. These are our charges now. But inside it, we have flows of ions going through. That positive, negative, positive, negative, 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 positive, negative flow of ions in it. That one we call it ions, which is comprised of cation and anion. But anions are the negative ions, while cations are the positive ions. But what they do, they exchange. Cathode and cation, they move hand to hand. They flow to each other, whereby anode and anion, they flow to each other too, because positive charge will go to negative ions, whereby negative charge will go to positive ions. That is how flow of current is. That's why we call it, you can call it electricity or electric current, because it requires ions moving for us to have our current. And we have mode of having a current. We have a mode of it. Then let's talk on conductor. As we all said, is the one that do what? Allow the flow of current. That is the conductor. And semiconductors too also allow the flow of current and does not also allow the flow of current in some instances. If you do it, it will allow the flow of current. If you do not do it, it won't allow the flow of current. And also we have an insulator. those one are the materials that do not allow the flow of current. Whether you do it, you not do it, without it to subscribe, it will not. Let's say examples of conductor now. We have our metal, e.g. metal, and so on. And then example of insulator, we have N-type and P-type. There are some materials whereby they are insulators materials. And also, they are semiconductor materials. And also, insulator, there are some materials that one is easily to get. But for the semiconductor, we have silicon and germanium. Those are the easiest semiconductor we can get. If you dupe it, it will allow the flow of current. If you not dupe it, it just be. And we have semiconductor types, which are the N-type and P-type. That's all about semiconductor. And for the insulators, these are the material that doesn't allow the flow of current. And we have some charge carriers. Those are the ones with antennas, cation, anion. Those are the ions. And the cathode and anodes, those are the charges. Because charges are different from ions. Charges are the cation and anion, whereby they are equidistant to each other, like this. They are equidistant, because these are equidistant to each other, cathode and anode. Then if it is ions, they are the ones that allow the flow of current. You cannot see it, but we can sense it and we can feel it. You put in electric charges, if you touch it, you feel it, but you can't see the flow of the ions in it. And we have some mathematical expressions for the electric current, which are what we call current, quantity, and the time taken for it. The quantity of electricity, which means the capacity is used, because no matter how things you are calculating, some must have the quantity, maybe 1, 2, 3, more than that, because you can't just do things without having the quantity out. We measure it. Quantity equal to current times our time taken. And then we have the mathematical expression as mathematically Q equal to IC. That is our quantity. And Q represents the quantity of electricity. And our I represents our current, the flow of our charges. And the time taken, because no matter how things are, we want to calculate, we must have our time taken for it to calculate. Because no matter whatever we are doing, we must have time for it. We have spent on it, whether moving out, or time is reading seconds. And we have examples we can check up on. The example says, if we have 4 coulombs pass a section of the wire in 2 seconds, calculate the current that passed through it. Like this now, let's recollect. The unit of current, is what it is in ampere, and our unit of time is in what? Is in seconds. And our unit of quantity of electricity is what? It is in coulomb. Then in this expression now, if we have 4 coulombs, which means our coulomb is what? it is in a quantity of electricity, which is we are given quantity of electricity as what? 4 coulomb, which is represented as C. 4C. Then we are also given pass a section of a wire in 2 seconds. It passed through a wire. This is the wire. Quantity of electricity passed through it, whereby we don't know in time taken. It passed through it in a time taken, whereby we are told to find the current that passed through it, which is at the aeon, the current that passed through it. Now we are given a time taken too, which says 2 seconds. Now our expression, we make use of this formula to calculate it. Q equal to IT. We are given Q, which is 4, and our I is what? 2, and our T is unknown. Our T is known, and our I is unknown. This is our I, and our T is known, whereby we have I is unknown. Now we write the expression out. 4 equal to 2 times I is the same thing as 4 equal to 2I. Then we make the subject of the formula. We make the I the subject of the formula. To calculate our I, it will go through like, we divide both sides by what? By 2. We get I equal to 4 over 2. The same thing as 2. We also do in the calculation, the same thing implies 4 over 2 give us 2. 2 was 2 ampere, because we have our unit for current is in ampere, or we make use of 2 equal to capital A. Let's check up on another example. Our example 2 says if a current of is passed through coulomb per second, the quantity passing a section in 10 seconds is what? That means here we were told to find the quantity of the electricity, and we recollect in our formula it says Q equal to IT. Our Q is the quantity of electricity, and our I is the current flow, and our T is what? Is our time taken in what? In seconds, and our current is in what? Ampere, and our quantity of electricity is what? Coulomb. Because now if a current of 4 coulomb per second or ampere, because anything like I, which is current, the unit can also give us ampere or coulomb per second. Reason for this coulomb per second is this. From the formula for quantity of electricity, Q equal to IT. If you make this I the solid of the formula, it will be like this. I equal to Q over T. Right? The quantity of electricity is what? Is in coulomb. And our quantity of what? Time. Our unit of time is what? Is in seconds. If you want to write it out, we can write coulomb per seconds, or like this, C per seconds, or C per second. The way we wish to write it, but normally the one they normally make use of is I unit. I unit is in ampere. That is the normal standard unit for electric current, which is ampere. I is ampere. But it might be given some questions, examples, whereby they might write coulomb per second is the same thing as ampere. Let's note that. And also our Q equal to IT from the question given. Q is unknown. Our I is known as what? 4 coulomb per second. And our T is what? 10 seconds. Let's compute our mathematical expression. Q equal to 4 times 10. Q equal to 4 times 10 will give us 40, as we all know. 40 what? 40 coulombs. That is the unit for quantity of electricity. And this is where we stop for the day till we meet in the next class.